Okay, so in number 5 and 9.2 or 7b, it says a researcher wishes to estimate the average blood alcohol concentration for drivers involved in fatal accidents who are found to have positive blood alcohol content or BAC values. He randomly selects records from 51 such drivers in 2009 and determines the sample mean BAC to be 0.17 grams per deciliter with a standard deviation of 0.08 grams per deciliter. Okay, so a histogram is showed to be highly skewed right. Explain why a large sample size is needed to construct a confidence interval for the mean. Let's remember for the mean, our initial conditions are that you need to have n bigger than 30, okay? So that's why he needs to have 51 drivers or a larger number of drivers. So because the distribution of blood alcohol is not normally distributed, it's highly skewed right, then the sample must be large, so the distribution of the sample mean is approximately normal. So that would be C. Recently, there were approximately 25,000 fatal crashes in which the driver had a positive blood alcohol. Explain why this, along with the fact that the data was obtained using a simple random sample, satisfies the requirements. Well, we need the sample size to be less than 5% of the population, so that's A. So question B is done. Question C, now they're asking us to determine and interpret a 90% confidence interval for the mean BAC. So a confidence interval for the mean, we're going to be using the t-test, and we need X bar, we need S, and we need N. So our X bar is our sample mean, which we found to be 0.17. Our S was 0.08, and our N was 51. So that's from here. There's S. There's X bar. And there's our N. So next we're going to go over to StatCrunch. Let's see. Hold on a second. Okay, here we are. So we want to do a confidence interval for the mean, which means we need a t-test. So we use t-stat, one sample with summary. Our sample mean was 0.17. Our sample standard deviation is 0.08. And our sample size was 51. And we wanted a 90% confidence interval, I think it was. And so we compute. So for the 90% confidence interval, we have a lower limit of 0.151226. I don't remember how many decimal places, so I'm just going to write 6 down. And an upper limit of 0.188774. Okay. And so now when we go back, It's down here, I think. There it is. So it was a 90%. Good thing I remembered. And we want 3 decimal places. So our lower bound and our upper bound means we are 90% confident that the population mean is in the confidence interval. So that's B. The first one says the researcher's 10% confident. We never talk about 10% confident. And the bottom one says that the mean is not in the confidence interval. No, the mean is for the confidence interval. We expect the mean to be in the confidence interval 90% of the time. So we have 0.151, and our upper bound is 0.189 when you round properly. Okay. Okay. So now we're going to look at part D. All areas of the country use a BAC of 0.09 as the legal intoxication level. Is it possible that the mean BAC of all drivers involved in fatal accidents who are found to have positive values is less than the legal intoxication level? So is it possible that the mean for the population is less than the legal intoxication level? It's possible, but it's pretty unlikely because we found the mean was between 15 and 18%. Let's see. It's possible that the mean is less than 0.09 because it's possible that the true mean is not captured in the confidence interval and is not likely. That looks good to me. Let me read the other ones and we'll see what's wrong with them. It's not possible that the mean is less than 0.09 because it is possible that the true mean is not captured in the confidence interval, but it is not likely. Well, if the true mean isn't captured, then it could be very low. So that doesn't make sense to me. It's possible that the mean is less than 0.09 because it's possible that the true mean is not captured in the confidence interval and is highly probable. It's not highly probable, it's just because it's less than 5% of the time that would happen. No, it is not possible because it's possible that the true mean is not captured in the confidence interval. No, that doesn't make sense either. So it is A. So again, we have a picture where 95% of the time we're going to capture the true mean, but it's possible that the true mean is outside of the interval, but very unlikely that it's going to be that much lower than the confidence interval. We talked about that the confidence level we get is based on a sample, so it could be off, but it's not very far off. And given that we're talking about these numbers that are between 15 and 18%, 9% is a lot lower than 15 to 18%. So it's just not likely. And that's the end of the question.